Let's talk about. First of all, let me tell you, proton has one P, one U, another U, and D. This is a proton. Proton has three quark flavors, two ups and one down. Okay. So what do you think? Is this proton called baryon or a meson? What do you think? Baryon or meson? You see, I told you what is baryon, what is
A
meson.
baryon, yeah.
Baryon. Okay. So it is going to be baryon. Yes, you're right. Can you tell me the resultant charge on a proton by using this U, U, D and their own charges? Try this. Plus 2 upon 3 E minus 1 upon 3 E. Okay, so it comes 3E
1.6 into
3.
1019.
Yes, it is actually coming plus E, right? That is
Yeah.
equals to 1.6 into 10 exponent minus 19 coulombs. And we know this well, right? A proton has a charge of plus E, right?
Hmm.
Fine. Another baryon is neutron. A neutron is actually UDD. Okay, U is for up, D is for down, and this D is also for down. So what is the answer? Is the answer coming zero?
Uh, 1 second. Yeah, 1 second. And the calculator is a bit confused.
Hmm. This is simply zero, and it must be
Okay.
zero as well because you know
Yeah, yeah.
neutron is a neutral particle. Okay, so neutron. This is how we solve these questions. I mean these things, right? So we must know about proton, we must know about neutron as baryons, and we must know these charges on each quark flavors that I told you. And we must know what is a baryon, what is a meson. And, this is a new topic, newly introduced topic in our syllabus that was introduced in 2016. That is not the very old discovery, it's a new discovery. And, this is something related to modern physics. And, anyways, so this is all about the quark model of hadrons, and this is all about this chapter as well, particle physics. Now I'm going to open some questions for you and we'll be solving them. Okay, give me a minute only. Okay, let's start. This is paper 1 2. Okay, so let's attempt all the questions of this chapter. Question number 38. This is a sample of an isotope emits beta negative particle. Okay, the emitted beta negative particle have a range of energy. What must also be emitted? So beta negative particle, along with beta negative particle, what other particles are emitted or particle is emitted? You remember beta negative emission we studied here?
Antineutrinos.
Yeah, anti-neutrino particle. Okay, so anti-neutrinos. One of them they have written anti-neutrinos, the other very close anti-neutrons. No, not anti-neutrons, but anti-neutrinos. Anyways, the next one is here. Again, a beta decay question, but this time beta positive decay. They said magnesium is decayed by, the beta positive particle. What are the values of P and Q? What do you think? 23 and P. Will there be any change in 23 or it will remain the same?
23 will remain the same.
It will remain the same. So P should be 23 only. P should be 23 only means either C or D must be the right option.
Yes, C.
And okay, decrease by 1. So C. Okay, there is another question. They said thorium 234 decays by beta negative emission into a daughter product. Okay, which is in turn decays by further beta negative emission into a granddaughter product. Means first thorium decays into a daughter, then daughter further decays into a granddaughter. Which letter in the diagram represents the granddaughter product? Tell me one thing, when beta negative emission takes place, what changes occur in proton number first of all?
Proton number +2 at the final product.
Okay, finally, proton number will be +2. And what about nucleon number?
It will stay the same.
It will stay the same. 234
So
remains 234, 234 remains 234, and proton number will become 92. You said it's B. Okay. In this paper, they have not asked about the Cork model of hadrons. So now let's do this one. Yeah, let's do this one. They said, which row describes the relative ionization power and the relative penetration power per unit length in air of alpha particle and gamma ray? Okay, so alpha particle least ionizing, least
C.
penetrating. Okay, you said alpha particle is most ionizing and gamma ray is most penetrating. Okay. Now the next one, a nucleus of sodium 21 decays to form a new nucleus containing 10 protons and 11 neutrons. Okay. Which leptons are emitted from the sodium 21 nucleus during the decay? Okay, so decays to form a new nucleus containing 10 protons and 11 neutrons. That was 11 protons. That were 11 protons now becomes 10 protons. And there were 21 minus 11 means 10 neutrons. Now they have got 11 neutrons. It means one proton is converted into one neutron. Okay, one proton is converted into one neutron. Do you understand?
Yeah.
One proton is decreased, one neutron is increased. What happens? I mean, what reaction are they talking about? Can you see? Converted into a neutron. Proton is
beta positive decay.
Beta positive decay. And what other particle is emitted with that? Neutrino particle, right?
Neutrino. Yeah.
Neutrino particle. So see, a nucleus of sodium. Okay, fine. So they say a positron and an antineutrino, a positron and a neutrino, an electron and an antineutrino, electron and a neutrino. Which one is the right answer?
B, because there's no electron.
Positron and a neutrino particle are emitted. Okay. Now the next one, they say a neutron decays to form a neutron is converted into a proton. Which particle is not involved in this decay process? Down quark, positron, and up quark. Neutron is converted into a proton. See, let me write.
Not antineutrino.
See, neutron, that is 0, 1, is converted into a proton, that is 1, 1 by emitting a negative beta particle, right? And along with that, an antineutrino particle is also emitted, right? So an antineutrino particle is also involved in this reaction. Tell me one thing. What is the core composition of neutron? UDD.
Oh yeah,
And what is the core composition of a proton?
UUD.
UUD. Do we have any quarks in electron as well?
Uh, you just
No,
charge E.
no. See, let me tell you one thing. I told you that, yes, I told you I started with,
Oh yeah, electron.
yes, quark model of hadrons, right? Electron
Yeah,
is
yeah,
actually not a hadron, it's a lepton.
yeah.
I'm writing here leptons. There are many leptons, but what we need to learn is negative electron, a positron, a neutrino particle, an antineutrino particle. All of them are considered to be leptons. They do not have any hadrons, okay?
Yeah.
Fine. So this does not have any cork flavors. This does not have any cork flavors. Now tell me, this U remains U. This D is converted into U. This D remains D. Okay. And electron remains same. Now, which particle is not involved in the decay process? Antineutrino.
Positron.
Okay, you said positron. Fine. Down quark is also involved. Okay, and positron is not there anywhere. Okay, so positron is the right answer. Okay,